Thanks, Elliot, and thank you everyone for coming today. So the forum today, I have the pleasure of introducing three researchers, Ken Clarke, Greg Wadley, and Ben Loveridge. They're here to overview projects being developed at the Melbourne Network Society Institute, or the MNSI. So the MNSI is an interdisciplinary research institute at the University of Melbourne, focused on understanding the impact of the increased connectivity between people, places, and things to create the network society. Ken is Deputy Director of the MNSI Lab. Greg is a lecturer in computing and information systems, and Ben Loveridge is Communications and Media Production Consultant in Learning Environments. So their talk today is Virtual Reality Projects at the Melbourne Network Society Institute. Please welcome Ken, Greg, and Ben for their presentation.
Yeah, good afternoon. As you just said, I'm Ken Clarke, Deputy Director, and thanks to sensiLab for inviting us here today to talk about our work. Virtual reality projects is just one small part of the work we do at the Institute, so I'll just spend 5 minutes in front of Greg and Ben just setting the scene for you to let you know where this work's coming from. There's a web link there down below, networksociety.unimel.edu.au. You can go to that and you can see a whole stack of research projects that we're involved in, as well as these virtual reality ones. So there are 5 interdisciplinary institutes. There's energy, there's network society, neuroscience, social equity, and sustainable society. And they're typically funded around about $1 million per year by the university. They're actually actively encouraging this interdisciplinarity as a way of bringing researchers from different silos, because traditionally, engineers would work with engineers, clinicians with clinicians. This is actually to cut right across the skill sets and actually get work going in between the gaps, as you like, as well as in the main domains. And of course, it's a way of attracting alternative funding into the university as well. So we have the Network Society, where we're looking at networking. It's actually powering by information and communications technologies. So we're substantially changing or modifying processes and outcomes of the economy, government, social fabric, and culture. So it's really all about that societal impact, this work, and that's where these projects are coming from. So this is a slide where we're obviously slap bang in the middle of this, so we're transitioning from the world population going up 7.1 to 7.6 billion, but in the meantime, all of these connected devices and people using the internet, etc., is exploding quite dramatically. So even if half of this is true by 2020, you're going to see something like a 2 or 3-fold increase in the number of connected devices and people across the planet. So there's a real driver there that we can use this connectivity to help have some impact in society. So our institute in particular, we're looking at the connectivity between people, places, and things. So you've got the Internet of Things, for example, but it's much bigger than that. It could actually link the people to new services, typically clinicians or educators, for example, wanting to reach into new populations or deliver services in a better way to people in outer metro and regional areas, for example. The Institute actually leads some research, and that's where this virtual reality work has come from. We're actually driving that at the university, but there's other research activities where we're more of a help or an aid, because we have certain specialist skills around telecoms, networking, software development, for example, and we have a sort of critical number, a sort of small team, but a critical level of skills so that we can actually help these projects get off the ground. So these are the main research areas, as I've mentioned briefly before, things around network living, so helping people live at home for a longer time, for example, so supporting independent living, enhancing educational outcomes, and similarly having an impact on the economy, shaping work and productivity, and even enhancing government services, and to the infrastructure itself, so establishing things around security and privacy are big issues for network society at the moment. It's very topical, and creating those innovative service delivery models. So that's again where this VR work's coming from. It's an innovative service delivery model having an impact on very particular groups in society. So the MNSI, we have a lab where, as well as software development and telecoms networking and ICT in general, it's just an active space where people can hire out various rooms in there and actually test between room to room, as if you were one end in the Melbourne city centre and the other end's in a regional town like Ballarat without the difficulty of that geographical separation. This particular scenario is for teledentistry, so the clinician there actually has almost like a toothbrush with a camera on the end there, and that footage is being beamed to a clinician in the city centre. So he's, as well as a view of the patient and dentist interaction, he's also got a view of the teeth and the problem in the mouth there. So he can do a triage or set up specialist services, for example. So some sample projects you'll be hearing from Ben and Greg just in a moment on VR for health. We've also got quite a few projects in that urban green space area, open food network, so again linking consumers with farmers and producers and wholesalers, so it's an alternative to the Safeway and the Coles model if you like. Digital vineyard, so the impact of drones and sensors on agriculture, that's a very, very big area for us. And it even goes, we even look at things like regulating automated legal services. So if a robo-lawyer gives you bad advice, who are you going to blame? You know, the robo-lawyer almost needs a lawyer itself, the way things are going. Even Bill Gates has said if robots are going to replace the workers, robots need to be taxed. Well, they also might need some legal advice as well. So there's all sorts of scenarios coming out of the network society. And the other area we have tele-rehabilitation. We work with clinicians not only at Melbourne Uni but also at Alfred Health and La Trobe, etc. Because we actually encourage external linkages. That could be other research institutes, universities, teaching hospitals, school groups, community health centres, etc. So again, this is one way of allowing people to stay in the home but then relay the data to a central clinician. So I'll hand over to Ben and Greg to talk about these two VR projects.
Thanks, Ken. So I'm interested, just a quick show of hands, how many people have used VR before, either the Gear VR or the Oculus or the Vive? Yep, excellent. So
everyone.
It's good to know.
Don't tell them what VR has been.
So thanks for having us today. I'm going to talk to you about our music therapy in virtual environments project that we're working on, and initially it wasn't a VR project to start with. I'm part of the learning environments team at the university, which is primarily focused on teaching and learning support, but we also work with researchers, and about 3 years ago Ken came to us with Jeanette Tamplin and asked us, is there a way we can have people sing together online in real time? And we thought, that sounds like a very challenging problem, and it has worked out that it is, but the hard problems are often very enjoyable to work on, which is what this one has been. So I'll give you some background first.
Spinal cord injury, breathing can actually be much more difficult because in addition to affecting the muscles that you use to walk, it also affects the muscles that you use to help push out air, for example, when you need to cough or when you need to project your voice. Big breath in. Good. Yeah. Ready? Big breath. And over. Prepared. Groups of people who with quadriplegia who sang together with music therapists versus people who came together in groups and did other music-related activities. And we found that there was a significant improvement in their ability to project their voice.
I think for someone in my position who is going to spend a lot of time in a wheelchair, it is difficult sometimes to move around. Using virtual reality, it makes you not think about your injury. If I had 5 people around me, I'd probably shy away from singing. But using that apparatus that we use, virtual reality, don't have any reservations in singing because it's like no one's watching it. That's why I tell you, you better be awesome.
So Jeanette Tamplin is one of the lead researchers. She's a music therapist, and she has been working with spinal injury patients for a number of years on improving their health by singing together. And what that does is that they can have a lot of lung issues because the muscles aren't the same as what they were before. So by encouraging singing, it gets the breath going and expands the lungs and helps their overall health, not to mention the social benefits as well. The challenge is that once music, once they're out of the Talbot clinic, for example, and go back home, the motivation to actually continue the singing is reduced, and it's very difficult to get people to come to the same room because of the costs involved. A lot of the patients are male, live in rural towns, so it might take a whole day to get to a clinic to do the 1 hour or 45-minute music therapy session. So the challenge that Jeanette came to us with is, can we replicate a group singing exercise online? So the accessibility is a problem. So a grant was given a couple of years ago for funding through the MNSI to look to solve this problem. And it's been going for quite a while, because you can see we've got the DK2s going. One of the first tests that we did was seeing whether or not the VR headsets, how they felt for the patients, because often with spinal cord injury patients, they can be very sensitive around the face, so that was one of the first tests that we wanted to do, and that didn't actually seem to be so much of an issue. The problem with networked audio is there can be, if you're using a wireless network, there can be a big latency. So to sing in time, you actually need to use a wired network and get all of the parts of the chain really accurate. So you've got that happening. So we went to a clinic for the initial testing, set up rooms next to each other. They were all connected through a wired network. So we were able to simulate what it's like and put everyone in different scenarios of the virtual headsets. And this is what happens when you count in time over a wireless network.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Jim was out of time, but you were in time.
So if you've ever tried to sing Happy Birthday over Skype or on the phone, one person will sound in
Just
time,
have
but
a
the
nice
other
gentle
won't.
pump. So nice deep breath in again.
So because of that, you can do certain exercises if you're not singing in time. And breathing is one example of an exercise you can do. Doesn't need to be in sync. But what patients really like to do is sing a song, and that was one of the key things. Just doing breathing exercises isn't that fun.
One more time. Knock, knock, knocking on heaven's door. Knock, knock, knocking on heaven's door. Knock, knock, knocking on heaven's door. Knock, knock, knocking on heaven's door.
To mimic singing in time, the delay between the people needs to be about 20 milliseconds, which limits how far you could go kilometre-wise. So we've tested within Melbourne and we've been able to get that working. We haven't tested beyond the CBD, but we think we could at least go at least a few hundred kilometres into rural towns, but we haven't tested that one yet. The experience of the VR, we came across some interesting things. When I was in VR, I wasn't thinking about pain or anything. I wasn't focusing on concentrating on my disability, and sitting in the chair was more like, wow, I'm sitting on a rock in front of a campfire. So the distraction from where they were was actually a factor that some of the feedback that we got.
There's the noise. You feel like getting up the chair and walking around.
Are you in space?
I am. This is cool. There's a planet there, there's well, that's Earth. I can see can't bring waves like Russia. There's a planet here up here, that's not Earth. Wow, awesome. Ah, look at that. You wouldn't want to be afraid of heights.
So at the moment we've been using off-the-shelf
Return to reality.
VR experiences.
That was cool. That was so awesome.
Yeah.
That was so awesome.
And you can see that the headphones audio feed was different to the visual because we're using a Gear VR, which runs wirelessly. The visuals are out of sync by a couple of seconds if you're talking to another avatar, but the audio was in sync. So if you're using a wireless headset, we have to run the audio separately through a separate system. So we have quite a few members of the team that have been involved in the process, and everyone's pitched in. Tom was saying before that the Anchor project will probably go for 20 years. This is another one that could go for 10 years or more because there's so many challenges along the way to solve, and we're a long way from getting there, but we've been able to at least get the audio separate to the vision. The biggest challenge is getting low latency audio through VR, because we've found PCs are really difficult with audio drivers to get them to be happy with really low latency. Macs work really well, so as soon as Mac hardware gets to the point where it can work with VR, we'll be certainly able to combine everything into one system. So there's been a few other future potentials of low latency networked audio, music online, going to concerts where it's real time, being able to interact real time if someone's at home with a concert, being able to experience something more in real time. There's a lot of apps out there that are, you'll see the latency, and if you try and sing with someone, it just won't work. But we think that if we can get the low latency audio happening with all the right pieces in the chain, it can open up a lot more other aspects as well. So keep on singing. Thank you.
Maybe you should take questions then. While I
Yeah,
answer
happy
those.
to answer questions. Yes.
So there's quite a lot of research going over a number of years in networked music performance.
Yes.
That you know, it's always entirely about latency.
Yeah.
How to deal with that. Have you looked into that much in the sort of computer music area and these kind of things?
Yeah, absolutely. That's what we've based our system on. So we're using a software called Jacktrip and another program called Jack, which was developed out at Stanford. So there's most of the networked audio was created in the early 2000s. They started working on this once broadband became quite good. So we're basing all of our work on this open source software and utilising that system. And it can work well.
It sort of struck me that it seemed like there were two things going on. There was the telepresence singing group experience and the virtual reality experience, which understandably for quadriplegics was both of those things were cool. But in some ways, from a research project perspective, it seems to me to be a bit muddy in the waters. I mean, to what extent would it be as effective, do you think, or not effective if you just had rather than a VR experience, just a screen and like with your headphones, and sidetracked all that wireless VR apps and
Yep.
so on?
Yeah, that's a really good question. And the next lot of testing, we're actually going back and doing more tests with those scenarios. So we're looking at testing just a video conference with a video view using Zoom, so it's fairly low latency, and seeing whether or not just doing it through a screen where you can see the other people without VR and audio, and comparing that to the VR experience, because that was something that, like, is VR even useful? Maybe, maybe not. That's something that we will now go back and test.
And one thing, I don't know if what you've done with regard to the audio spatialization, but one area where I can imagine VR would be good in that group singing experience is if it properly spatialized the audio so that, you know, when you turn your head to the person singing over there, things like that. Is that what it does?
So that's, in that example it didn't, because we were just using a mono lapel mic for everyone, so their audio they were hearing was here. The challenge is because we can't get audio running through a PC, we can't get it into Unity to then spatialise the audio through Unity. So we've been looking at, one of the steps I want to test is binaural audio, and then seeing if we can do real-time binaural, say an ambisonic.
There's lots of applications that might be, or, you know, allow you to do that. If you're running the audio
That's right. So it's just a matter of can you then take the head tracking data and apply that to a
Yeah.
sonic mic and then
And that's
real
where
time do that.
a number of research projects, particularly in acoustic ecology.
Yeah.
So not really.
Yeah, definitely. Very keen on finding out more of that. So thanks.
Ben, there's another question.
Yeah.
I was just Googling it and couldn't find it. What was the software called you used from Zen with Jack?
So Jack is one part of it, which allows you to route audio from your computer to different devices, and then Jack Trip is the software that sends the audio, packetizes it, sends it to another computer in as close to real time.
But
as
it's
it
spelled like Jack, like the name.
Jackttrip.
Yeah, okay. Cool, thank you.
Ben, I just have just a general question about VR. I mean, we're always talking about the potentials of it, and everyone's obviously very excited with the relative novelty of it. But what are some of the drawbacks that you see aside from just the obvious one of motion sickness? Did this come up in any of the interviews with the participants? Did anyone say anything about what they didn't like about VR?
From a technical point of view, it's very fiddly still. So you would need a carer to put the headset on them. The wires, there's a lot of aspects there. The Gear VRs that we were using overheated every 20 minutes, so they're getting better as we go on. But we're having the conversation about whether we would go with an Oculus Rift versus a Gear VR. The benefit of, say, using a program like VTime is it's gaze-based. So once the headset's on, the participant can just use their head to navigate to a particular room, invite who they want, and do everything that way. They're not relying on someone using a mouse and a cursor. So there's lots of pros and cons, and it depends a lot on the context of how this may be used. If it's at someone's home, it's got to be as easy to use as possible.
Yeah.
But you might sacrifice some of the more real-time benefits as well from a visual point of view. So.
Yes, and I guess in those particular examples you showed there, it really was about bringing people together into a space, and I guess there wasn't any of this loneliness that people can experience if they're in a VR experience all on their own, which doesn't involve other people and networked in, right? Yeah. Okay. Yeah.
Yes. I mean, you probably didn't see it, but when they were in separate rooms, they were joking around to each other, talking about the
And there was
scene
always
that they
someone
were
in the room with them, usually.
Well, we were going between the rooms, but if they were at home, they would always have a carer with them, just to physically get their headsets on.
Okay.
Should I go?
Yeah.
Hello everyone, I'm Greg. I should stand here, should I? Just circle around the room.
There's no way you can't be seen.
So I'm talking about VR for youth mental health. I'm part of a team, and I've got everyone's photos on the next slide, including Ben who just spoke. So Reva and I are in the computer science department. Reva's a bit more IS, I'm more in the HCI group. And Mario and Sarah are researchers and clinicians at the Origin Youth Mental Health Clinic. And John used to be at Origin, and now he heads up psychology at ACU. And we've been working together for 7 years on different technology ideas in youth mental health. We inspire ourselves by asking, what will a mental health clinic of the future look like? And it may not look like that, but we think that it won't look exactly like the clinic of today. The clinic of today looks much like the clinic of yesterday. So the actual mechanics of psychological therapy has not changed much. So people come to a bricks and mortar clinic and they sit in a room with a counsellor, psychologist, social worker or whatever for their 30-minute or whatever session, and they're having a conversation, they get up and leave. They do that repeatedly over time. So we wonder especially whether emerging technologies are going to help to change that picture and become part of mental health care. So if we pose that as a question, we think the answer is obviously yes. And there's a lot of work happening around the world to bring contemporary consumer technologies into mental health care. So we've been working in this space since 2009. So far, until we started this VR project, we've been working on web and phone apps. And a lot of people around the world are working in this space. And the basic idea is kind of an obvious idea really, and that's to address the delivery, to try and change the delivery of mental health care, and thereby change its accessibility to people. So mental illness is a huge problem. Everybody knows that's getting a lot of publicity lately. It represents 30% of the non-fatal disease burden in Australia, which is a very high number. It's also a problem, especially for young people. So a half of psychiatric disorders appear by the age of 14 and 3/4 by the age of 25. For that reason, the boss at Origin, Pat McGorry, has described mental illness as the chronic illness of the young. So, in spite of, or perhaps because of the size of that problem in society, there are not enough bricks and mortar clinical and human clinical resources to deliver all of the care that's needed to all of the people who need it. And so technology becomes part of that picture in the same way as technology is transforming so many aspects of life. So the fundamental idea, I guess, is you digitise some kind of face-to-face experience, and then once digitised, it can be pumped out over the internet to people at times and places convenient to them. Not only are there not enough clinical resources, there's simply not enough clinicians to do all the work that's required, but it can be very difficult for a young person to get to that clinic week after week for months or possibly years, especially if the young person doesn't live near the centre of a large city. And for people with a mental illness, simply making that journey can be very confronting. So getting on public transport, for example, can be a real issue. And for that reason, despite this real shortage of clinical places, there's a lot of no-shows. So people don't turn up to their appointments. So we've been exploring that space for years. We've got a good collaboration going between the sort of technology people and the clinical people, and figuring out how to do design work in the clinic, how to do evaluations in the clinic, and so on. But more recently, we've been wondering whether VR can be useful for youth mental health. So we're working on this project now, and this is different to the web and phone. The basic idea is a different one. Currently in our VR project, we're not so much interested in the transport issue, in the delivery of therapy. Initially, at least, we're trying to transform the way therapy works as a face-to-face experience. So if we get that right, and it seems to work, then later on, VR might also become part of that transport issue, that delivery question. But for now, we're just working within the face-to-face therapeutic experience. We've got some support from MNSI, that's Ken's group who spoke about, and that's allowed us to get some gear and get some great developers on board. And this is our vision, and please let me make clear that this is work in progress. I'm not presenting final results, these are still ideas we're working on. But this is our vision, written in the second person, so when you don the headset, you'll be transported to the centre of your own mind in an illuminating, powerful and empowering experience. You'll experience the mind's dynamics, learn powerful therapy tools and manipulate mental processes with your own hands. So this is a simulation of the psychodynamics of the mind. Because a lot of mental health therapy with young people involves psychoeducation, so learning about how the mind works and what might have gone wrong for a particular person, and then how to deal with that. So as I said, this is to be used, at least in this early phase, at the clinic, at the bricks and mortar clinic, as part of regular face-to-face consultation. So just some of the ideas, just to illustrate where I think he's going, I'll just show you. These are not screenshots, these are part of our design process. So this app is called Trains of Thought, and you put on the headset and you appear at a train station. And you can walk around the train station, and there's some very limited interaction with objects. But the main game is that you're on a busy platform, and trains are coming to the platform and leaving the platform. And the trick here is that the trains represent troublesome recurring thoughts. So people with depression, with psychosis, are often troubled by unpleasant, unhelpful recurring thoughts. And just to throw examples, just for illustration, thoughts like, I'm hopeless, I'm worthless, nobody likes me, I have no future, these kinds of things. And so some of the techniques influenced by mindfulness therapy in how to deal with those thoughts. And so the basic idea of the train station is that, and by the way, we represent the thoughts on the train so that we can type in text and the text appears on the train. It's actually quite confronting reading something like that coming down the platform at you, but it kind of has to be. And the idea is that these thoughts arrive, and you can observe them, and then they leave. And you don't have to get on board, as it were, and be taken where that thought wants you to go. So that's the message here. And there's a similar message in this app we call thought bubbles. We're not sure whether to have a background in this. You can't. It looks a little washed out, but in our design sketch we have a kind of greyed out background. In different versions of this, we're turning backgrounds on and off. Because really the user here is in their own mind. And by the way, they're not represented. That's a design sketch. But the user sees their recurrent troubling thoughts appearing as balloons or thought bubbles. It's a little bit like the thought balloon in a cartoon, although we're not connecting the thoughts to the person's head. And again, you can watch the thoughts appear. There's some limited interaction, and eventually they fade away. They bob around in the breeze. So a very simple app that we hope gets across a powerful message. These techniques are already taught in the face-to-face therapy. So the technique isn't new, but the visualization and making it an experience is new. We don't think anyone else has done this yet. The problem with the way these techniques are taught, they're taught in a kind of verbal way. So someone will explain to you in much the way as I just did now, okay, you need to imagine your thought as a train and you're standing at a train station or whatever. It's hard to convey that to a young person. Young people don't particularly like sitting for half an hour having some adult explain stuff at them. It can be difficult to get across these abstract ideas. The kids are often quite distracted and they're not really in a great frame of mind. They don't really want to be there. And so often that education process, getting across that therapy tool does not actually work. And we hope that by doing it in VR, we solve some of those problems. But I'm going to mention some other work that's going on in VR therapy, and that's how I'll wrap up. People are using, and have been using VR for as long as they've been workable systems to create exposure therapies for phobias that involve stimuli such as heights and spiders and flying, and there are others. And the idea here is that you simulate that anxiety-inducing experience, and in a controlled, careful and safe way, you re-expose the phobic person to that stimulus, and eventually the phobia will diminish. In a similar vein, researchers have used VR to recreate traumatic incidents that military personnel on active duty have experienced, and thereby treat post-traumatic stress disorder in returned soldiers. And this VR therapy is already being used in several hospitals in the US. Going beyond phobia, there's a couple of VR projects in the UK that are geared at people who experience paranoia. Some of these are people who have psychosis. This is the virtual bar. I'm not sure how clear that is, but you are at a bar. There are other people at that bar, and some of those people do socially confronting and challenging things like stare at you and so forth. Another one is on public transport. So it's interesting hearing about the VR train project, or the graphical train, simulated train earlier today. So in one of these experiences, you go through the entire public transport experience, buying a ticket, going down a long elevator. These are confronting experiences for someone with paranoia. But the people on this train, like this guy here, he's staring at you. That's pretty confronting, right? I haven't experienced these myself. I've only seen videos, but I understand that in the bar, people in groups will look at you, start laughing, and look away. Right? So if you're suffering from paranoia, you can be exposed to this in a safe environment. Like you know you're in VR, you know you're not really in the bar, And that exposes the person gradually, and apparently it works really well for paranoia. VR has been used for pain relief, for accident and burn victims, especially again with young people, and also anxiety pre and post operation. And this in a way is kind of the inverse of that. So here we're simulating the bad experience, the anxiety-inducing experience, and exposing someone carefully to it. In this situation, the person's already in a bad experience. They're in hospital, they're suffering great pain, and VR allows them through psychological transport or the sense of presence to feel as though they are somewhere else, and apparently that's quite effective for pain. This rather clever experiment was published last year. This is to induce self-compassion. So people, again, with severe mental health problems often are very self-critical, and this can exacerbate their emotional problems. So what happened in this experience, you put on the headset and you see a small child who's crying, suffering, the child is upset, and you comfort the child. But then there's a clever plot switch, and you become the child. And there's an adult avatar, which is you, and all of the comforting words you said to the child are now replayed to you. And so the lesson there is that you are worthy of compassion, because people in this situation often don't feel that they are. And furthermore, that you can be compassionate with yourself. So you're not criticising every possible failure, but you are compassionate. And finally, I'll mention the virtual human lab at Stanford. Not really working with mental illness here, but rather trying to enhance socially desirable personality traits, such as prosociality, or the willingness to help others, and empathy. So this experiment's well known, I'm sure some people will have heard of it. So this is the superhero experiment, so you control your movements by moving your arms around. You're a superhero, you're above a virtual city, and there's a lost child somewhere down there. The child's in trouble of some kind, and you fly down and you rescue this person. There's a control group here, and the control group are passengers in a helicopter that effectively do the same rescue. And what they do then is to measure the difference in prosociality induced between these two groups. I think the way they measure prosociality is really fascinating. A collaborator of the researcher, immediately after the person takes their headset off, they're in the admin room filling in some forms, and someone knocks over a bucket of pencils. And they count how many pencils the person picks up. and you get a difference between the two groups. That's a recognised measure of prosociality. I think this is really interesting because in this work here, and I think in most of the work they're doing it in this Stanford lab, these people do not have a mental illness. So if you have a mental illness, you've kind of come to an agreement with doctors, perhaps with family and friends, that there's a mental state in there that's gone bad, and you need to change it in some way. But this is for all of us. So the basic premise is that prosociality is a good thing, and would it be possible for technology to induce or enhance that in people? So I think that raises a whole stack of really interesting issues, which I'm not going to try and cover in a short talk. I will mention one more project. So this is the Liminal VR startup. Are they a startup? I think startups are originally working. So it's a small group working in Melbourne, so a commercial company. They haven't released this yet, but there's a lot of really interesting chat happening about it. So you can read on their website here, this VR will induce a range of cognitive and emotional states. It gives you the ability to control and augment your state of mind. And informally, I've spoken with one or two of the people from Liminal, and they talk about dialing up the emotion that you want. And in an interview I saw with them online, they used the example of you're at work, and there's a really important meeting coming up, and you're feeling a bit anxious, and maybe you need to get into a different frame of mind in order to achieve this very important work/social goal that you have coming up. Well, what would we do without VR? We might reach for a coffee or go outside and have a cigarette, or perhaps do some meditation or something. And Liminal are exploring the possibility that VR can induce the feelings that we wish to feel, that we think are useful for us to feel now. So I think it's really interesting that VR has already been used, I'm wrapping up now, already been used in mental health, where there's a clearly defined problem, we need to fix that problem. And now we're moving into something that might be useful for everybody. Are there mental states that could be diminished or enhanced in order to help people achieve their goals? So yeah, work in progress, we're building and testing, and I'll wrap up there. Thank you.
Guys, we've got another 15 minutes or so. Is there any questions for Greg or Ben or anything else to do with the org? I have a few, actually.
Fire away.
About those projects, those exposure projects that you had, like you were mentioning a mind project, and particularly the one about exposure paranoia, staring virtual people. Is that? I was very interested in that because that's something that Elliot and Mike and I are actually we're working on similar things at Monash at the moment with OCD, with the neurosciences over at Monash Clayton campus. How are these scenarios put together in virtual reality? I'm just wondering if you know, do you have live actors who motion capture the gestures, for instance, staring at someone or interacting with it? There must be a human in the loop somewhere, or is this pre-animated? And what point do live actors come in to kind of act out these scenarios and make these virtual, I guess, these characters that you're meeting and interacting with, what makes them seem real?
Short answer, I don't know.
Yeah. Okay.
So the exposure therapies there are both UK projects,
Yeah.
and I don't know anything about the manufacture of the VR. I've seen video of the VR itself. They're animated characters.
They're animated, yeah.
But whether they are avatars with behaviour built in, or whether they've done some motion capture, I'm sorry, I don't know.
I'm just wondering about how that plays into the participants' experience, you know, with exposure therapy. I mean, this is something we're dealing with right now. How realistic do the environments look? Are they overly realistic? Will people kind of, I guess, you know, are the participants familiar enough with computer games and to accept a kind of reality? Yes, they understand it's constructed reality.
Sure.
But they're still going to kind of play the game. They're still going to kind of, they're going to have that suspension of disbelief.
I think that's a really interesting question. I think we know from the history of computer games that the games don't have to look that realistic for people to get very engaged in it. There's also the uncanny valley problem. I'm often asked, is it safe to give VR to someone with a mental health problem, especially psychosis where they have delusions? You know, is there a risk that it will be too realistic and the person might feel confused about whether they're now in VR or real reality? And I think that's related to what you're asking. And I think that the answer to that is in the foreseeable future, it's not a major risk. I think because although, you know, there's a lot of hype around how realistic VR is, it's not that realistic really. I had this struck me just recently when Ben was showing me some new VR that he'd acquired, and it was just amazing. It was such a great experience visually. It was a fantastic experience, and yet the whole time I was completely aware that I was standing. I could feel the weight of the headset. I've got restricted vision. It's always a bit cartoony. You know, this was an underwater thing. I could tell that I wasn't really underwater. And I don't believe in my own mind that we are at risk anytime soon of people being genuinely confused about whether they're in VR or not. So, to circle back to your original question, how realistic do the gestures have to be?
Yeah.
I don't know. I mean, I think people just kind of do the best they can.
It's getting easier now though with touch controllers and the Vive. You can do really cheap motion capture, whereas 3 or 4 years ago you had to have an expensive rig or the suits. But even now Facebook have just released their own VR spaces, so you can record and capture genuine human motion, even though the avatar's a cartoon. The motion is quite realistic because the head, the body language, and just from being in social VR a fair bit, that still feels real. Even if it's robots looking at you, they're kind of moving because you know it's a human behind there, and that feels real.
But Ben, are you ever confused about whether you're in VR or not? It does feel real, and they're very compelling experiences, but do you ever get confused?
It's a real experience, but you don't confuse it with reality. You know that you're in a virtual room, but it still feels like you're speaking to real people behind there, like a Skype call. You know it's a screen, but you're still interacting with a human behind there.
In that example of exposure therapy, I mean, you might be leading the participant into this train where there's all these passengers looking out the window, and someone is looking at them. How do you know that that's not an avatar of a real person looking at you through the medium of the, that would make you extra paranoid, you know. You don't know if it's networked and there's someone else.
Sure.
These aren't all artificial characters, there's actually a person behind them moving that character, yes.
So those, like the one we're working on, those ones are used within the bricks and mortar clinic, and someone is explaining, there's someone there sort of coaching them through it. But I can imagine if that was made available for download, then yeah. I don't know, I guess you're right, there's potential for confusion about whether you're actually in a multi-user system and someone really is staring at your avatar or something. Sure.
That's interesting example.
I really love the idea of the thought bubble popping trains of thought therapy thing. I wonder whether there's potential for some real-time biometrics, heart rate, oxygen level, cortisol level, and so on, that could, or EEG, I suppose, that could, so that you can tell when someone's getting stressed out of that train of thought.
Yes. There is that meditation app. Who did that one?
Guided meditation is where you put your heart, you tell it what your heart rate is, and then it gives you something. That's not real time.
There's that one where you levitate. If you can get your heart rate down enough, your avatar starts to levitate.
I haven't seen that one.
I can't remember who's doing it.
Okay.
I mean, look, there's been a bunch of EEG neurofeedback kind of trying to relax, and the more relaxed you get, the more relaxing it is, and so on. But a lot of this real-time biometrics are quite advanced now. You wouldn't have to do that. You just
Would be interesting.
stress levels or something.
And how would you put where the words that are on the train as it comes in, using that metaphor, are they taken down at the beginning of the session? I mean, how do the words get on the train? Or is it something the person says that is then put into text-to-speech? I mean,
in these early versions, there's simply a second screen. So there's the visualization that the young person has through the headset, and there's a second screen displayed on the clinician's computer, and so they can just type in and press a button.
Okay.
And so there's a lot of controls on there that control different areas.
So they can type in keywords that the participant has mentioned to them that bring about a mental safe stress or something.
Yeah. So if you're the clinician and it's now time for the next patient, that patient, you've got their file, you understand what sort of troubling thoughts they have, and you can sort of prepare it for them. And you can imagine where we could go with that, so you could build up a database of common thoughts perhaps and dial them up. We've experimented with having neutral thoughts in there as well, and with colour coding the thoughts, so according to emotion, so we can have angry thoughts and sad thoughts and neutral thoughts, so colour coding. So you could, in principle, of course, store strings of text for individual patients, and perhaps even have that be part of the clinical information system.
Right.
Yeah, but we're not doing that in the prototypes yet. It's just purely manual. We're going to finish early, I think. Everyone's eager to get back to work.
If there's no further questions, I'd like to thank Ken, Greg, and Ben for coming in today. Thanks very much.